Distributed File Systems Demystified, GFS, HDFS, and Building Systems that Scale. How do tech giants like Google and Facebook store and process petabytes of data across thousands of machines? The answer lies in distributed file systems, the backbone of modern data-driven applications. In this video, I'll show you the core principles of designing a distributed file system, how systems like Google File System, GFS, and Hadoop Distributed File System, HDFS, achieve scalability and fault tolerance, and pro tips for designing your own distributed file system. If you're ready to dive into the architecture behind the world's most powerful systems, let's get started. A distributed file system, or DFS, is a storage system that spreads data across multiple machines while making it appear as a single logical file system. It provides users with seamless access to files regardless of where the data is stored physically. These systems are designed to handle massive amounts of data, ensure high availability, and scale effortlessly with demand. Let's talk about two of the most iconic distributed file systems, Google File System, GFS, designed to handle Google's search index and massive data operations. Hadoop Distributed File System, HDFS, the open-source counterpart that powers Hadoop ecosystems worldwide. Both systems tackle similar challenges, but have unique design philosophies. Understanding GFS and HDFS isn't just about learning their architecture. It's about unlocking the secrets to building systems that scale. Here are the fundamental principles behind distributed file systems like GFS and HDFS. First, chunk-based storage. Files are divided into fixed-size chunks, distributed across machines. Second, replication. Each chunk is stored on multiple nodes for fault tolerance. Third, a master node or name node maintains metadata and coordinates file operations. Fourth, fault tolerance, with automatic recovery from machine failures. And finally, high throughput, optimized for sequential reads and writes, not random access. Let's break down GFS. Files are split into 64 megabyte chunks. A master node stores metadata like file locations, while chunk servers store the actual data. Clients interact with both master and chunk servers for efficient reads and writes. GFS is like a well-oiled factory. Every part works together to handle massive loads efficiently. HDFS, inspired by GFS, follows similar principles but with a few key differences. The name node manages metadata while data nodes store chunks. It's optimized for batch processing, making it ideal for Hadoop workloads. HDFS emphasizes high availability through block replication, typically with 3 copies of each block. Where do distributed file systems shine? Well, let's dive in. Big data analytics. Systems like HDFS are the backbone of data pipelines in Hadoop and Spark, content delivery, storing and distributing massive video libraries or file repositories, and of course, scientific research, handling petabyte-scale datasets for simulations and experiments. From streaming your favorite shows to decoding the universe, distributed file systems power it all. Designing a distributed file system isn't without its challenges. Let's talk about a few. Metadata bottleneck. Master nodes can become a single point of failure. Consistency versus performance. Balancing strong consistency with high throughput. Node failures. Handling frequent failures in large clusters. Now, here are some best practices. Use replication strategically to balance fault tolerance and storage costs. Implement efficient garbage collection to handle orphaned chunks, and monitor cluster health and scale metadata storage as your system grows. My top tips for designing your own distributed file system are: 1. Use chunking and replication for fault tolerance and scalability. 2. Optimize for sequential access to maximize throughput. And 3. Design with failure in mind. Because in distributed systems, failures aren't rare, they're the norm. With the right design, your file system won't just handle data, It'll redefine what's possible. To recap, distributed file systems like GFS and HDFS are built to scale, handle failures, and process massive data volumes. Core principles like chunking, replication, and master nodes ensure reliability and performance. Learning from these architectures will give you the tools to design resilient systems of your own. In our next video, we'll dive into CAP theorem and distributed system trade-offs. Don't miss it. If you're ready to level up your system design skills and build architectures that scale to infinity, hit subscribe, turn on notifications, and join me for the next deep dive. Because in the world of big data, it's not just about storing information, it's about building systems that never fail. Subscribe to Hustler Coder, GFS and HDFS, the secret to scalability. New videos every week.